Okay guys, so gonna post another video and I wanted to show you some of the basics parameters that I use on these drives. The rest of the stuff I don't even touch it. It works good for me, you know. So parameter number on this Chinese drives, and they work. The manual for this full version and the simple version, which is a smaller one, they both got the same parameters, and it's the same manual for this than for the smaller servo drive that I put on the Brothers. You know, those little 1 kilowatt, $100 and something set. Yes, it's the same parameters, the same. They probably using the same software microprocessor on both of them, and maybe different power or whatever. Anyway, I'm gonna try to go to the basics of what I normally look at when I'm powering on one of these. They really can preset pretty nice. So PN 0 PN02 is the first one I look at. PN02 have to be set to 2. That's control mode. That's going to be the kind of control mode that we're going to be using on it. And that one is going to be positioning control mode. Okay? And then after I check that that one is the one it's set up to, because that's the way we're going to use it on positioning control mode. Then I come out of there and go to PN. This is the only thing you really have to do, I'm telling you, if you're going to use them on a CNC, really. Later on you can do finer tuning on it, and I'm going to touch a little bit on it, but I haven't had to do nothing else on this kind of drives, either one of them. And PN03, you gotta make sure it's on 0. You do not want to enable this servo as soon as you put power to it. So pretty much you can put power to it and make sure you can turn the bolt screws on it, or you can turn the motor, and there's not the driver is not engaging the motor on torque, because you don't know what could happen. Maybe just like I said on previous video, I'm gonna be confident on that when I power on, it's not gonna be enabled. It's completely disabled. You can power on and still go to the bolt screws. And now in this scenario here, I'm already enabled this drive with the C34 control board, breakout board, that comes information from the C76, and it will enable the drives through Mach 3. But anyway, make sure 02 is on 2 and 03 is on 0. And then we're gonna jump to maximum speed. They claim, when you buy them, they claim they're only 2500 RPM set up. They're set to 2500 RPM, and that's what the motor says on the motor. But they actually is PM51. 51. They're preset to 5000 RPM. I hope you're getting that. I don't know, maybe not. Anyway, that's closer. So they preset to 5000, as you can see over there, and I just leave them over there. I'm not gonna turn them that high anyway. We don't need to. But they preset to 5000, so that's one thing I really check. PM51. I'm gonna back out of it so to make sure. PM51. So we did PN02, PN03, and PM51. Some of this I know them by heart because I have played with them before. So, I'm sorry. So the next one is gonna be command pulse input mode. So we're gonna use a step and directions. We're not gonna use a step and a speed and stop, like step and speed. We're not gonna use wait, don't forget, forward, reverse, or quadrature pulse. I don't know how to say that word. Anyway, so the first thing we need to make sure, at least on Mach 3, that we're gonna be sending step and direction, and the driver is gonna be okay with that. And the way to set up that is on PN 96. So we're gonna go up here to 96. Then we're gonna jump over, put a 9 here, and we're gonna enter in there. We're gonna make sure it's on 0. So 0 means it's set up to pulse and direction, right? So just to make sure, we on PN96. That's one you gotta make sure you're gonna be using pulse and direction on the drive, and the driver is gonna be okay with that. The next one you're gonna be checking on is the instruction pulse input direction logic selection. That means which way do you want your motor to be turning to. Just for saying, this is my C-axis, and I'm glad I'm sitting on this one trying to show you this. This is my C-axis. I'm gonna go to PN97, and I'm gonna enter here. I gotta set up to 1. I'm gonna get on this one, PN97. I gotta set up to 0. So see, there's difference here because I want my C-axis to turn a different way than my Y and X is turning to. The reason for that is, I'll show you. I can't show you right now. So gonna reset Mach 3 because I already got it set up. I'm gonna come here to the front of the machine. I'm gonna mount this here so you see what I'm talking about, and hopefully you get it from there. So I'm on C-axis. If I turn down, it goes down. Down or up, right? The way it's supposed to be. And if I come back here, maybe this video is going to stand a little bit longer than what I thought. I'm going to reset Mach. I'm going to come here where I got a 1, and I'm going to put a 0 on it, hold it to set it, and I'm going to turn that drive off just to make sure it will save that information. I'm going to reset Mach 3 again. Try to do it the quick as I can. See? Now is the wrong way. Now, I know some of you are going to say, you can do that on Mach 3. Yes, I know. I know I can go to Mach 3, just right here, ports and pin, motor, and I just need to click on C-axis and put it high, right, instead of low. But, to be honest, I like to see this looking like that. I want it to look like that. I want it to look all the same way. Just me. You do it the way you want. It doesn't hurt me. But I'm just telling you, I know you can do it here, but I don't want to do it there. I want my drive to do what I want after I got all my setup done the way I want. So I'm gonna go back here to my PN so I don't forget and destroy something. PN97, jump 97, get in there, and I'm gonna put a 1 on it. I'm gonna save it. I'm gonna come out of there. And then, so you saw that one. That one is just to make the motor go one way or the other way. Now, the next parameter I'll be looking at is my gearing on it. So, the electronic gearing on it, which is PN98. So PN98, hopefully you understood the first, the one we talked about just a minute ago. PN98 is your gear ratio, your electronic gear ratio. I have problems, not problems, but I have situations with Mach 3 that I want to turn higher speed, and at the same time, if I got too much pulses coming out of Mach 3, it will not allow me to have a lot of acceleration and a lot of step per. So what you do, you need to turn this up. So they normally come from the factory by default at 1. Default is 1. So 1 pulse over there, it will not generate any pulse. It will just it will not multiply any of the pulses. So, but I set it to 8. So I want 8 times. I want this to multiply 8 times whatever I'm sending for Mach in here. So that way I can turn Mach 3 over to 1,000 inches per minute at 5,000 pulses at 50 of acceleration, which is not much for some people, but for me it's plenty. And Mach 3 is not gonna try to default back to not enough acceleration or too much acceleration, all that kind of stuff. So I set this one to 8, so you gotta play with that. You gotta play with your gear ratio if you want Mach 3 to allow you. It's just like changing your settings on your step and direction. On your stepper motor, like when you change the pulses up here because you want it to turn more or whatever. That's the same here. That's the gear ratio on your drive. But remember, that's P098. And the other one, or the other two, that these are very important, and I hope you don't miss this part. These are the two. Don't forget about this, because if you use one of these, you're gonna run into a situation like this 100%. So 258, PN258. PN258 is the gain adjustment mode. So the driver is gonna adjust the torque, the amperage, voltage, all kind of stuff on it to make that motor run the right way. Getting information, feedback from the encoder, amperage, load on the motor, all of that stuff. It will create that closed loop. So you can either do it automatic or you can do it mechanically. If you do it mechanically, then you have to adjust it yourself. But I always let it automatic. It works for me. Maybe you know how to set it up better. I have tried and I cannot do it, so I leave it on automatic. That's PN258. Leave it on 0. Okay? Go to PN258 and make sure 58. So we're gonna jump. We're gonna go down to 5. We're gonna jump again and go to 2. PN258. I'm on the wrong one. Yeah. That was me playing with it. I left it on 1. It should have been to 0 or 1. Yeah. I believe it's got to be to a 0. but we're gonna check on that right now because I don't want to mess this up here. 257, 58, 0 is manual, for automatic. Yeah, it's set up right. So if it's set up to a 1, it's automatic. It's the right weight right now. So it's set up to 1, it's automatic. I'm mistaken over there, but yes. Shouldn't be to a 0, it has to be set to a 1, which is automatic. Once it's set up to automatic, what you do is you got PM59. Let's go out of there. 59. And then your 59 is your rigidity, mechanical rigidity. Depending on how heavy and how much, how easy does your motor runs or move your mechanical parts, like your ball screw, how heavy is your table, all of that, you will have to go up and down on that rigidity so it doesn't create a vibration. I'm gonna demonstrate that right now, and because I have to lower these ones. Actually, on the Brothers, I have to turn it up. It came on a 5, and I end up putting on a 7. On this one came on a 4, so rigidity goes from 0 to 20. So this one came on a 4, and I have to lower down to 2. If you see over there. So I have to lower it down to 2 because I was having a lot of vibrations on the table. So pretty much the motors, they were handling the ball screw so easy. And if there's some like right now there's no weight covers on, it's so light. I might have to change that later, but it's so light, the table is light for it, that it will it will create those vibrations. So I turn it down, and this is my C-axis. I shouldn't do that with the C-axis. Demonstrate that, because I don't like to play with my C-axis when I don't have, like all my tool changer stuff like that. So I'm gonna leave this one alone. I'm gonna go out of there, go out of there again, and I'm gonna go to my Y-axis. Yes, let's play with this one here. 258, 58. I forgot. 59. So 59, we jump, go down to 5, jump again. 2, no, too much. 9, jump. 5, 259. So that's my rigidity right there, right? Okay. So right now I'm not gonna touch it. I'm gonna stay on 259. I'm gonna come here, reset Mac. Let me go get my MPG. I'm gonna sit you here. Yeah, I wish I had a light. I had a light here somewhere, but I took it to the house. Let me get my MPG, and hopefully you see something of what I'm talking about. So I'm gonna move my C-axis. My Y-axis. It's not that bad. You hear that humming, that whining, or whatever. So you could blame that to the ball screws, but I'm gonna show you what I'm talking about now. So let's reset Mac so we don't play with that. Then we're gonna enter on 259, and I'm gonna turn this up to, I'm gonna turn it up to 5. Hopefully I don't make crazy stuff here, but because they will get like they want to go crazy. So I'm gonna come out of there. I'm gonna turn the driver off, turn it back on, enable driver, and we're gonna try that again. So I'm gonna go slow first. You hear that? See how much vibrations? That is the motor trying to hold so tight the position that will create vibrations on the whole bolt screw, framing of the machine. All of that will vibrate with that motor holding, trying to hold that positioning with the encoder feedback. And see how loud it is? The whole machine shakes when it stops. And so that's it. I'm gonna go back to it because I don't want to leave it like that. What's this one here? Hopefully you get information out of this that so it's 59. We're gonna put this on a 9. We're gonna jump, put a 5 here, jump again, 1, 2, enter, there, put it down to a 2, set it, come out of there, turn off the drive, turn it back on, and it should be fine. Let me move this door again. Then I gotta hold it this way. We don't have room. We don't have room here between. So it's set already, and so you see how much vibrations with that translate or transfer to the body of the machine, and it looks like it's gonna be your. It looks like it's gonna be your bolt screws, and you might end up sending the bolt screws away to someone to fix it, and it's not actually the bolt screws. It's just the setting on the drive. That motor is trying to hold the position so tight, and those hertz over there on the motor is trying to hold so tight that will create that really high frequency vibration into the bolt screw, and that will transfer to the whole machine. So that's a really good tip that I would say you should keep on that. The other thing that I don't know if I talked about that, the PN61. Did we talk about 61? PN60, 51, 61. Oh yeah, PN61. Now this is on this drive for my setup, and when I say my setup is the, this breakout board, the C76, and all of the rest of the other boards from CNC from PC, and the C34. So if you want this Mach 3 to know through the C34 and the C76 through the UC300, and then to Mach 3 to know that you're going to, one of the drive went off, and it will reset, will e-stop the system, just like on another machine. You got to set up on this setup PN61. PN61 is an output that sends an alarm. It will send a signal, alarm signal, out to the control board, and that control board will alarm the Mach 3. So I can show you like right now. Mach 3, even if I turn the driver off, you know, that drive is not, it's not an alarm. Turn it back on, Mach 3 didn't disengage or nothing. I can even pull this out. Mach 3 is not, it hasn't reset. Now, if I reset Mach 3, I'm gonna come here, I'm gonna alarm this servo out. And this is a good way to try it out. Oh, they're loose. I'm gonna take the encoder off, and I'm gonna turn the servo on. When I turn it on, it's gonna set an alarm. It's gonna set an alarm on that axis. So you'll see now. Hopefully you see it. See, it set an alarm. Alarm 09. I'm gonna try to turn Mach 3 on. Safety charge pump is blinking, and it's gonna go off. It's gonna go off. Why? Because the driver is sending an alarm through this RJ45 connection into Mach, and the UC300 is alarming out, you know, resetting Mach 3. So I'm gonna put no settings or nothing. See, Mach 3 resetted itself because I unplugged this from the drive. So for some reason you alarm out one of the drive, Mach 3 will reset. I mean, your machine is not just gonna keep running and breaking stuff and all that. And that will also happen if you want to on these two wires right here. I hope you can see it, that I got jumped out. This one here is stop, and this one here is a spindle drive. So you can hook your spindle drive to this, set it, and once you set it up, if your spindle drive will alarms out, it will happen the same. So let's just say you overloading your spindle and your drive went to alarm. You use that to create a signal, and that signal is going to reset Mach 3. Everything is going to stop. So you're not going to keep breaking stuff on the whole machine. So I'm going to put the encoder back. Okay. Turn the driver on. No alarm on it. I'm going to reset Mach 3. There it is. No alarms. So no alarms. Mach 3 is fine with it. As soon as we try to do something with the servo, Mach 3 is going to alarm out and reset. So the machine is not going to stay running. Okay, guys. So I'm going to wrap the video for now. And I hope you get some good information out of this. That's a simple way to set these servos. They already come preset pretty good. One of the most important one is the 250, forgot, 59, yeah, 259 rigidity. That's really important. It will create all kind of noises and stuff. You're gonna think, you know, either the servo is bad or your machine it wasn't built good and all that. No, most of the time, I would say 99.9. It's not either one of them. It's just your settings on your servo. So set up 259 the best way you can. Tune it up so where you can always hear a little bit of humming, but that humming means your motor is actually trying to do the best it can, you know. So you got to tune that up, you know, until any of this machine, you know, that sharp over there with final controls, and many machines you can hear them when they moving. People think, oh, they're gonna need bolt screws. No, they're not gonna need bolt screws. It's that servo is trying to hold that bolt screw so hard in position with the feedback on the encoder that is creating that humming. So besides that, this is not compared to nothing like Fanuc or nothing like that. I'm not comparing that, but what I'm saying, it can be tuned to your needs if you want to. Okay, well, good night. I hope you like it, and the build is coming together. I got a bunch of stuff in that I'm gonna start putting on. I got some pretty cool ideas. I don't know if you noticed, I changed my power supply position. Move it up here because I forgot that I ordered this, and then this came in. You know, it's a fused deal, so I can use all my 24 volts going to everywhere that I need on my 24 volt. They're gonna be fused to everything. So yeah. So right, enjoy the video, get information out of it, buy you an old machine, and build it. I'll help you. We'll do something good. I'll get you information or whatever. Good night. Bye.